The next point is trigonometric functions of sums and differences of two angles. Let's say we have two angles A and B. Then sine of A plus minus I'm writing B is equals to sine A cos B plus minus cos A sine B. Fine. And sine A plus B plus sine A minus B is equals to 2 sine A cos B. Fine. Because sine of A plus B plus sine of A minus B, that will be sine A cos B plus cos A sine B plus sine A cos B minus cos A sine B. So the cos A sine B element will get cancelled with the positive term. Negative term will get cancelled with the positive term. And the sine A cos B will come twice. So 2 sine A cos B. Similarly, you can write 2 cos A sine B for 2 cos A sine B for sine of A plus B minus sine of A minus B. In this case, you cancel the first term. Okay. Now, similarly, you have formula for cos of A plus minus B. That is equals to cos A cos B minus plus sine A sine B. Okay. So, similar things you can do with cos also, that 2 cos A cos B if you want, then you will add both the terms. And if you want this sine A sine B, then you will subtract the two terms, cos A minus B minus cos A plus B. Okay. So, next one is sine square A minus sine square B, that is equals to cos square B minus cos square A. First of all, let me tell you this one, that sine square A plus cos square A is equals to 1. This you learn in 10th mathematics. The sine square A plus cos square A is 1, and from here you can calculate that sine A is root of 1 minus cos square A, or cos A is root of 1 minus sine square A. Okay. So these things you learn in 10th mathematics. I am using it here. Sine square A, I can write it as 1 minus cos square A and minus 1 minus cos square B. So this will give you cos square B minus cos square A. Hence, and this is also equals to sine of A plus B into sine of A minus B. Okay. Now, fourth formula, cos square A minus cos square B. Cos square A minus sine square B, sorry. Cos square A minus sine square B, that is equals to, well, cos square B minus sine square A. You can see that these two interchange. Okay, when you convert cos into sine and sine into cos, this is equals to cos of A plus B into cos of A minus B. Of course, because cos of A plus B, cos of A minus B, sine of A plus B, sine of A minus B. What are they? These things. So when you multiply A plus B into A minus B, that will be A square minus B square. A plus B into A minus B, that will be A square minus B square, where A is sine A cos B and B is cos A sine B in this case. Okay. Now we'll move on with some more formulae. Next one is cos of A plus minus B in terms of cot of A plus minus B. Cot of A plus minus B. I'm not writing 10 because 10 you can easily manipulate. So from cot also you can manipulate 10. Cot A is, cot of A plus minus B is cot A cot B minus plus 1 upon 1 cot A cot B plus minus cot A, or cot A plus minus cot B. Okay, so this is the formula for cot. Similarly, for 10 you can write A plus minus B will be 10A plus minus 10B upon 1 minus plus 10A 10B. Okay, these are simple. 10 of A plus B is 10A plus 10B upon 1 minus 10A 10B. Okay, like 10 of 53 plus 27 you have to calculate, then 10 of 53 plus 10 of 27 upon 1 minus 10 53 10 27. Okay, now the next formula, which is not so important but can be used, 10 of A plus B plus C, that is 10A plus 10B plus 10C minus tan A, tan B, tan C upon 1 minus tan A tan B minus tan B tan C minus tan A tan B tan C. Okay, this is the formula for tan of A plus B plus C. Now we'll move on to the next set of formula, which consists of the factorization of the sum or differences of two sines and cosines. These are pretty much important because they are mainly used in IIT-JEE. Sin C plus sin D. This is equals to 2 sin C plus D by 2 cos C minus D by 2. Next one is sin C minus sin D. That is equals to 2 cos C plus D by 2 sin C minus D by 2. Okay. Now, third one is cos C plus cos D. That will be 2 cos C plus D by 2 cos C minus D by 2. Fourth one is cos C minus cos D. These are pretty much important and I will tell you how to learn this easily. 2 sin, let's say minus 2 sin, okay, minus 2 sin C plus D by 2, or you can write this minus as this and cos D minus cos C, okay, and this sin C minus D by 2, or you can transfer this minus into this sin, okay, D minus C. Now, first of all, sin C plus sin D. Sin of A plus B plus sin of A minus B, which we saw first, it was this. Sin of A plus B plus sin of A minus B is 2 sin A cos B. Just like this, we will put A plus B as C and A minus B as D. Then what do we get? A will be, if A plus B is C and A minus B is D, then A will be C plus D by 2 and B will be C minus D by 2. Just like that, you can calculate this thing, okay, and you can convert it into sin and sin. Fine. Now, sin of C plus D, if sin are added, then you get sin with the added term C plus D and cos with the negative term C minus D. If sin are subtracted, then you will get sin as the subtracted term and cos as the added term. Okay, 2 factor is common in all the 4. What I'm telling you is when to use this plus and minus, because all the people are confused in this. So when sin are added, then you will use the whatever this sign is, you will use it in sin and the opposite in cos. This is negative, so the opposite is positive, so you use that positive in cos and the negative in sin. Cos C plus cos D. In case of cos, you just write either both the cos or both the sines. Okay, if you are adding it, then you will use both the cos. If you are subtracting it, okay, this is the subtraction, then you will use both the sines. Okay, now C plus D and C minus D, it's just simple. Okay, if you are dealing with cos, just use both cos. If you are adding, if you are subtracting something, then you will just use negative sign. For sin, you will just use the sign in the left hand side, just like in the right hand side for the sign variable. And for negative, the sign is negative and cos is positive. Okay, so this is how you remember this type of formula. Now, we'll move on to the multiple formula. Okay, multiple formula like sin of 2a, that is 2 sin A cos A. Similarly, cos of 2a, the cos of 2a has 3 formulae. First is cos square A minus sin square A, or this sin square A can be written in terms of cos square, that will make it 2 cos square A minus 1, or this cos square A can be written in sin square A and that will make it 1 minus 2 sin square A. Fine. So these are the 3 formulas for cos 2a and 1 formula for sin 2a. Similarly, you can write this 2a in one form, like as a single, angle. So cos A will be what? Cos square A by 2 minus sin square A by 2, or 2 cos square A by 2 minus 1, or 1 minus 2 sin square A by 2. Okay. So this is the thing, that if you change 2A to A, then A will change to A by 2. Okay. All the angles will get divided by 2. Then you have sin 2A in terms of tan 2A. These are sin 2A in terms of sin and cos A. This is cos 2A in terms of sin and cos A. Okay. And these two, what I am going to do next, are sin and cos in terms of tan. So sin 2A is 2 tan A upon 1 plus tan square A. This is plus tan square A. Okay. Whether cos 2A is 1 minus tan square A. Remember the thing that this is 2A and this is A. Okay. In left hand side we are using 2A, and the right hand side we are using A. So 1 plus tan square A. Okay. Now we have 3 angles. Sin 3A, which is equals to, sin 3 will be 3 sin A minus 4 sin cube A. 3 sin A minus 4 sin cube A. Similarly, cos 3A is 4 cos cube A minus 3 cos A. Now this is also easy to remember. This thing is replaced to cos, and the sign is exchanged. This is positive here, this is negative here. This is negative here, this is positive here. Okay, and sign is changed to cos. So you have to remember just one formula, sin 3A, and cos 3A, you will get it. Now cos 2A, 1 minus tan square A upon 1 plus tan square A. Sin 2A, 2 tan A upon 1 plus tan square A. Similarly, you have tan 3A. Three tan A minus tan cube A upon 1 minus 3 tan square A. Okay. Now we'll move on to the important trigonometric ratios. The first one is when sin n pi is 0. Okay. N can be anything. If n is 1, then sin pi is equals to 0. N is 2, sin 2 pi is equals to 0. Similarly, for n belongs to natural numbers, not natural numbers, integers. Okay. That will be 0. Okay. Now, cos n pi is minus 1. Any pi. Okay. Tan n pi, of course 0, because tan n pi is what? Sin n pi upon cos n pi. That will be 0. Now, I'm going to, dictate some 15 degree angles, 75 degree angles, which you have to remember. So first of all, sine of 15 degrees, or you can write sine of pi by 12. That is equals to root 3 minus 1 by 2 root 2. There is an explanation, but I'm not going to do it because it's not necessary for you right now. Cos 75 degree, or is equals to cos 5 pi by 12. How is that? Because 15 degree plus 75 degree is 90 degree, and sine of theta is cos of 90 minus theta. Okay. That's why sine of 15 degree will be equals to cos of 75 degree. 90 minus 15 is 75 degrees. Okay. So that's why. This is one relation. Then we have next as cos of 15. You can calculate it using the sine of A is root of 1 minus cos square A. But I'm just going to write it, because if you know this one, okay, this is important. If you know this one, then you can calculate any cos of 15, tan of 15, all these above. Okay. This is also equals to cos of pi by 12. That is equals to root 3 plus 1 by 2 root 2. Okay. The sin square A plus cos square A is also 1. So you can remember with this also. And this will be equals to sin 75 degrees or sine of 5 pi by 12. And tan of 15 degree will be what? This thing divided by this thing. Now we'll move on to 18 degree angles. Sine of 18 degree is root 5 minus 1 by 4. Cos is equals to cos of 36 degrees. Okay? It's not cos of 36 degrees. I'm sorry. Cos of 36 will be root 5 plus 1. Okay? These are important. That root of 10 plus minus 5 root 5 root 2 is not important. So I'm not telling you that. That's 10 minus 2 root 5 something by 4. But that's not important. In JEE, they have always asked the two of these. Sine of 18 and cos of 36. And related to these. Okay, pi by 5. This is pi by 5 and this is pi by 10. Okay. That's it. Now, range of trigonometric expression. Whenever you have trigonometric expression of a sine theta plus b cos theta, the range will be, this is important, a square plus b square, a square plus b square. Okay, this is the range for trigonometric expressions. Now, sine and cosine series I am going to tell you about. Sine series, sine of alpha, this is important. Sine of alpha plus beta plus sine of alpha plus 2 beta. Okay, this is 2 beta. Up to summation up to sine of alpha plus n minus 1 beta. This is equals to sine of n beta by 2 sine of alpha plus n minus 1 by 2 beta upon sine of beta by 2. Okay, this is the sine series. That if you are asked that sine of 10 plus sine of 11 plus sine of 12 plus sine of 13, like that, in that case alpha will be 11 and beta will be 1. So, or alpha will be 10 and beta will be 1. Then up to 20 you have to write the summation. Then you can just use this thing, that n is equals to 10, beta is equals to 1. So 10 upon 2 sine of 5 degree. Here 10 and n minus 1 by 2, 9 by 2, beta is 1. So 4.5, so 14.5 degrees. Beta by 2, that is 0.5 degrees. So sine of 0.5 degrees. And now you got the answer. Similarly, you have cos series, cos alpha plus, similarly cos of alpha plus beta plus cos of alpha plus 2 beta plus cos of alpha plus n minus 1 beta is equals to cos of, is also equals to sine of, and that is sine of n beta by 2. Here it is cos alpha plus n minus 1 by 2 beta, right? And upon same sine beta by 2. Okay, so this term is same, the sine beta by 2 and sine n beta by 2. This term is same in both. Only this term has changed, which is cos here and sine here. Okay, so this is sine series and cos series. They can ask you any question about how much is beta or something like that. Okay, then now we'll move on to the trigonometric equations. Trigonometric equations, I'm going to write it with red. These are the specific topics and you should learn about it. Principal solutions which there are principal solutions in this. Okay, principal solutions. These are the solutions. Like if you have trigonometric equations like sine of theta is 0, then theta has theta has a set which satisfies this property. Hence, there are some principal solutions. Okay, this is a solution of theta. This set is a solution of the theta. Now, these principal solutions are solutions which lie in the interval 0 to 2 pi. 0 to 2 pi are principal solutions. Okay, whereas general solutions, first you have principal solutions which are in this range, which is the 1 to 4th quadrant. Okay, the all 4 quadrants, but not progressing about it. Then you have general solutions for if sine theta is equals to sine alpha. Like sine theta, sine of 45 is given sine alpha, then theta will be what? Like that, right? So theta is n pi plus minus 1 to the power n alpha. Okay? Where alpha belongs to, of course, the first quadrant. Minus pi by 2 to plus pi by 2, and n belongs to integers. Okay? Now, moving on, the second general solution is for cos theta. Of course, cos theta is equals to cos alpha. This implies theta is equals to 2n pi plus minus alpha, where alpha is what? Again, the range, the domain of 0 to pi. Alpha belongs to 0 to pi, because in that sense only you have n belongs to z. Okay, because 0 to pi is what? The first and second quadrant. In that case, cos is positive. In this first quadrant, sine is positive. First and fourth quadrant, sine is positive. In first and second quadrant, cos is positive. That's why 0 to pi by 2 and pi by 2 to pi. This includes first and second quadrant. Similarly, you have tan theta is equals to tan alpha. If you get this, then theta will be equals to n pi plus alpha. Okay, where alpha is again sine, where alpha belongs to, of course, not included this curly bracket. This is not a curly, this is open bracket. Minus pi by 2 to plus pi by 2, open bracket closed. Okay, then n belongs to integers, of course. Then you have